First, let's compare the two experiments. In experiment 1, the current is 0.9 ampere. In experiment 2 is 0.3 ampere. The brightness of lamp is more than the brightness of lamp in experiment 1. From the above experiment, we deduce that X decreases the brightness of lamp by decreasing the current passing through it. The name of X is a resistor. Resistor is an electric component designed to resist an electric current. It converts electrical energy into thermal energy. A resistor is characterized by its resistance R. The SI unit of resistance is ohm. To convert from kilo ohm to ohm, we multiplied by 1000. To convert from ohm to kilo ohm, we divided by 1000. The electrical symbol of a resistor is. The resistance of a resistor can be measured directly by an instrument called ohm meter or multimeter. The ohm meter should be connected in parallel across the terminals of the resistor, like this. The symbol of the ohm meter is. Okay. Consider the following table. Here we have the values of current and here we have the values of voltage. If we represent or convert this table into graph, we place the values of current on the horizontal line and the voltage on the vertical line. So we notice that these points make me a line or makes a straight line, but this straight line is passing through the origin point 0 or O. So we can deduce or we notice that the IV characteristics, like current voltage characteristic, is a straight line passing through the origin. Same table, but here another characteristic of resistor. Okay. If we divided the first value of voltage 10 over 0.1, we get 100. Then U2 over I2, also we get the same value 100. U3 over I3, also we get 100. Finally U4 over I4, we get 100. So we notice that all these values are the same. So if we subtract or we take 2 points, point 1 and point 3, and we subtract the voltage between U3 and U1, also current I3 and I1. U3 minus U1, 30 minus 10, we get 20. I3 minus I1, we get 0.2. If we divide 20 over 0.2, we get 100. So U over I is equal to K, and this ratio is equal to the resistor. So Ohm's law equal U, or U equal R times I. Ohm's law states that the electric current intensity traversing a resistor is directly proportional to its voltage. From this formula, we can find resistor and current. To find the resistor, we divided voltage U over I, current. And if we find the current I, we divided the voltage U over resistance R. The resistance of connection wire is negligible or zero. If resistance is a wire, equal to zero. If the resistance of, of an ammeter is negligible, also equal to zero. The resistance of a voltage is huge. Resistance can be used as a protection device for applications from high current. Now, connection of resistors. We have two connections, series connection and parallel connection. Series connection experiment. If we measure the resistance of R1, we get 10 ohm, and for R2 is 15 ohm. Now, if we combine them and measure the resistance between these two resistors, we get 25. Now, to find the R equivalent of these two resistors, R1 and R2, we notice that R equivalent is the sum of R1 and R2. R1, R2, and R3 are in series. These examples. Low uniqueness of current. In series connection, the current are equal. I1 equal I2 equal I3 equal I. Low addition of voltage. The voltage بالseries are addition. To find the total voltage, we can add U1, U2, U3. And equivalent resistance is the sum of all resistance we have. If we have R1 equal 10 ohm, R2 20 ohm, R3 15 ohm. Calculate the equivalent resistance R1, R2, and R3. Okay. Answer: R1 and R2 and R3 are connected in series, so the R equivalent is the sum of these two resistors, R1 plus R2 plus R3. 10 plus 20 plus 15 equal 45. Parallel connection experiment. Okay. If we measure the resistance of R1, we get 10, and also for R2 we get 15. If we combine them but put R1 over R2, the value is 6. So the formula is 1 over R equivalent is equal 1 over R1 plus 1 over R2 plus 1 over R3, etc. Here, if we make same denominator, we multiplied R2 here and R2 here, R1 and R1. So we get R2 plus R1 over R1 times R2, and we inverted the equation, so we get R equivalent equal R1 times R2 over R1 plus R2 equal 10 times 15 over 10 plus 15, we get 6. Low uniqueness of voltage. Okay, to find the total voltage in parallel, the voltage are the same, like this. If these two resistors are connecting in parallel, the voltage of R1, R2 and R3 are the same. In current, we add the values of I1, I2 and I3. So I1 plus I2 plus I3 equal I. And equivalent resistance 1 over Re, or R equivalent, equal 1 over R1 plus 1 over R2 plus 1 over R3. Okay, if we have R1 equal 6, R2 equal 4, and R3 equal 12, and they are connecting in parallel. To find the equivalent resistance, we use the formula 1 over Re equal 1 over R1 plus 1 over R2 plus 1 over R3. So we replace the values of R1, R2 and R3, 1 over 6 plus 1 over 4 plus 1 over 12. If we make same denominator for 6 and 4, we get 2 plus 1 plus 3 over 12 equals 6 over 12. But here we will get the value of R equivalent, not 1 over R equivalent. So we will invert the equation. Re equal 12 over 6، يعني بنقلبها نحط 12 فوق والستة تحت بيطلع عنا 2. Special case connecting. If we have two resistance are connecting in parallel, R1, R2, we can use the formula Re equal R1 times R2 over R1 plus R2. Example, R1 equal 3 and R2 equal 6, and they are connecting in parallel, so we can calculate the R equivalent in the formula R1 times R2 over R1 plus R2 equal 3 times 6, 18, and 3 plus 6 equal 9, so 18 over 9 equal 2. Mixed connecting or connection application. If we have the two cases, parallel connection and series connection in the same circuit, R1 equal 12, R2 equal 8, R3 equal 1.2. First, we can calculate R1 and the R equivalent of R1 and R2. So we can use the formula R1 times R2 over R1 plus R2, and we get 4.8. Now these two resistors are 1 and connecting in series with R3. So we can use the formula of connecting series, which is R equivalent equal R E1 or R1 plus R3. We get 6. General application 1. R1 equal 60, R2 equal 30, and R3 equal 20, and I1 equal 1 ampere. Now, 1. Calculate Re in this circuit. To find the R equivalent of these resistors, first we will find the R equivalent of R1 and R2. Then we will find the equivalent resistance of these two resistors with the third resistor. Now R1 and R2 are connecting in parallel, so we can use the formula R1 times R2 over R1 plus R2, we get 20. Now RBC and R3 are in series, connecting in series, so we will add them to get the R equivalent for 40. Calculate the UBC voltage BC across R1. Now let's see what we have in R1. I have the resistor R1 and the current I1, so I can find the voltage by Ohm's law. R1 times I1 equal 60 volt. Now show that the current carried by R2 is I2 equal to. Here R1 and R2 are in parallel, so the voltage of R1 is the same voltage of R2. So now I have the resistor R2 and the voltage, so I can find the current by Ohm's law. I2 equal U BC over R2, and I get 2 ampere. Deduce the total current I. Total current I1 and I2 are connecting in parallel, so I will add the value of I1 and I2 to get 3 ampere by law addition of current. Calculate the UAC and R3. Now here I have the resistor, the value of resistor R3 and the total current I, so I can apply Ohm's law to find the voltage across AC. We get 60. By using two methods, show that the total voltage is U equal 120. First method, apply Ohm's law. I have the total current and the total resistance, so I multiplied them to get 120. Second method, these AC and BC are series, so the voltage in AC and BC, I will add them to find the total voltage. UAC plus UBC equal 120.